What's up everyone, welcome back to another episode of Workshop Rebuild. In today's video I have everything laid out from the Kohler K532 and I'll share with you every detail on how to reassemble this engine. I previously did a teardown video on the Kohler K532, so if you haven't dismantled your engine yet, you can click the card up above on the top right of the screen so you will have some help dismantling your engine at home. In this video, I'll cover all the aspects of this engine and I'll try my best to explain all the components involved in this reassembly. If you find this video helpful in any way, I'd really appreciate it if you hit the like button down below, and if you have any questions, leave a comment as well. If you want to see more videos about engines or machines in general, consider subscribing and don't forget to hit that bell notification. Right now, I'll bring you guys in for a close-up view on the engine block. I'll give you guys some details on this engine block and then we'll start with the rebuild process. This right here is the engine block and I'll give you guys some specs and details before we move on to the assembly process. The engine spec itself hides within the name of the engine, so Kohler K532 actually means K is the K series. 53 is about 53 cubic inch of displacement within this engine block. The actual number is 53.7 cubic inches, so it's a very rough estimate. And the 2 within the name means 2 cylinders, so left and right, and this is an opposed engine, so that's why we have 2 cylinders. I'll leave a link down below so you guys can decipher your own engine model and suffix, so those 3 letters that are behind the K532. This is a 4-stroke engine and it runs on gasoline, so your biggest giveaway on a gasoline engine is a carburetor. That carburetor will sit right above the engine. This right here happens to be the top of the engine, and the carburetor will sit right here and it gets hooked up to the intake manifold, which then goes to our intake ports. This engine has a pressurized lubrication system, so what that means is it has an oil pump. That oil pump provides oil to our cam bearings. That oil pump provides oil to all our main bearings as well as our rod bearings throughout this engine. So to some real facts right now, the standard bore for this engine right here is 3 3/8 of an inch, and the metric conversion I'll leave on the screen. The stroke happens to be 3 inches, so what that means is the piston moves in and out of the cylinder exactly 3 inches. Each piston has 2 compression rings and 1 oil ring, so that's a pretty good setup in general, and I will get into more detail on the pistons and talk more about the bore and piston measurements later on in this video. The engine displacement is exactly 53.7 cubic inches, which allows this engine to rev at 3600 RPM, and that will give this engine a max output of 19.9 horsepower, and that's why most people say this engine technically has 20 horsepower. I just shared with you guys some information that's readily available on the internet, so I'll leave links down in the description so you guys can access that information yourself. Right now, I'll start the assembly process and I'll do my best to give you guys some proper angles, so let's go. So I have the engine right in front of me. I'm going to start on this surface. This is a machine surface and we will have our flywheel on this end of the engine. We have 2 bearings. One is for the camshaft, that is the top one, and the bottom bearing is for the crankshaft. We will focus on the camshaft first, as well as the lifters that are involved within this engine. In the background, you guys can see 4 lifters, and this is the first one. So when we look at this lifter, it is still in great condition, and this is an original lifter. There is no step in any way, and I measured this with the mic, and it measures just fine, so I can reuse this. The top end of this lifter has a bolt within the lifter, and it has a spring inside, so this is spring loaded, and it will always keep the correct distance. This adjustable head allows you to adjust the valve clearance, so your valve will be on this side, and then you can adjust the valve gap right between the lifter and the valve. So we're going to install these 4 lifters first into the engine block, and I'll give you guys a close-up view on the inside and where I install them. Before I add the camshaft into the bore, which is the bottom bearing, I want to add a whole bunch of assembly grease into that bearing. Just like that, and I'm going to rub it all the way around the perimeter. Make sure every spot is touched. I just installed the camshaft, and now I'll add the backing plate. This acts as an adapter for a cover plate. There will be a gasket which lies in between, but I'm just going to put this here temporarily and add the 3 bolts which get mounted behind the cam gear. These bolts have lock washers behind them, so you guys can thread them in until they touch the plate. I have the crankshaft on the white table. I put the block aside. We're going to have a good look at the crankshaft first, and then we'll mount the crankshaft into the engine block. So I have the crankshaft in front of me. I'll share with you guys the details on the crankshaft. I'll start my way from the middle outward to the right and then to the left. In the middle, we have 2 connecting rod journals. These are polished to perfection, and they have a certain diameter to fit the connecting rod inside diameter. That is this diameter right here. This is the bearing of the connecting rod. These connecting rods do not have a wear bearing. They are just fully machined within the connecting rod itself. So this corresponds with the outside diameter of the connecting rod journal on the crankshaft. We have 2 because this is a 2-cylinder engine. Off to the right of this crankshaft, we have another bearing diameter. This will be held by our radial bearing. This outside diameter is once again polished to perfection, and this will fit within the radial bearing. That is a very big radial bearing that we have within this engine. It is also held in place with the snap ring, so that will lock the radial bearing in place from this face of the crankshaft to the snap ring, which goes into that groove. On this surface right here, which is a little bit narrower than the radial bearing surface, we will have a double lip seal that will hold all our oil within the engine block. On the very outside, we have a certain length of shaft with a keyway. This will allow us to have an adapter, a pulley, or something on the end of the crankshaft so we can power something. In my case, the John Deere 400 will have a double pulley on the very end, so that will have a key inserted within this keyway, and that will transfer then power to the double shiv pulley. On the left of the crankshaft, we have once again a bearing seat. This one happens to have a groove, but these 2 surfaces are ground to perfection, and these will fit within our block. And there we have a sleeve bushing, which is pushed in to the engine block. Off to the left of the main bearing, we have another machined surface. This diameter is a little bit smaller than the main bearing. We have a keyway, and the key is still inserted in the crankshaft as of right now. This area will hold our timing gear. This gear is held in place on the crankshaft, so that will be put in place right there. This will then transfer our timing to our camshaft gear. The camshaft gear is much larger, and the camshaft gear will then mesh in with the crankshaft gear, just like so. The crankshaft gear is held in place once again by a snap ring. This snap ring will be inserted within the crankshaft on this height. Off to the left of the timing gear surface, we have a little portion which is still smaller in diameter, and here will be our double lip seal, and this will be a smaller one as for on the other side. We have 2, one on the right and one on the left, and this will be the end of our engine block, and this will house all our oil, so everything within the 2 double lip seals will hold all the oil within the engine. Off to the left of that seal, we have an outside portion of the crankshaft. Just like on this side, this is outside of the engine, and this side of the crankshaft is outside as well. The tapered surface, as you guys can see right here, is also slotted for a key, and we have our flywheel on this end. So the taper will hold the flywheel in place, but it'll also be held in place with the key. To secure the flywheel in place, we have a threaded portion on the crankshaft, and we will have our nut on the very end, and that will be torqued to perfection so the flywheel does not come loose. So I just shared with you guys some really important information on the crankshaft. So now let me get the crankshaft within the block, and then we'll have a look at the end play. I turned the engine block around and I suspended it at the same time. So we're looking at 6 inches below the engine block, so I can insert the crankshaft vertically down into the engine block and place it into the bearing. Before I insert the crankshaft, I want to make sure that everything is lubricated. So there is one bearing down below and there is one face which the crankshaft will touch on. So I will make sure that is lubricated before I insert the crankshaft. So I placed the crankshaft within the engine block. It is touching the bottom surface of the engine block. And now I can go ahead and take the front plate, which holds our main radial bearing. This is a very big bearing. And the crankshaft has a step or a seat for the inside of this radial bearing. So we're going to make sure this radial bearing pops on the crankshaft very snug. And at the same time, we're going to have to add shims between the engine block and this cover. That will allow us to manipulate our end play, and the end play will be on the screen so you guys will have that measurement. The iSafe Tractors gasket kit comes with 5 different gaskets. There are 2 shims which are a little bit thinner, and there are 3 shims which are a little bit thicker. Right now I'm going to take one of the thicker shims, place it between the block and the cover, make sure everything is tightened up so I can measure the end play with my gauge. If the end plate is too little, I'm going to add some more. If it's too big, I will add a little bit less. So let's figure this out. Everything under or above is not good enough. So I will go ahead and grab my gasket. This is just one of the thicker gaskets in the iSafe Tractors gasket kit. I will take my Ultra Blue Permatex gasket or silicone, and I will add this on both sides of the gasket to make a proper bond, but I will only add a thin layer so it doesn't gush into the engine when I compress this. The 4 bolts that I have ready for the plate will have to be torqued down to 30 foot-pounds. I have a torque wrench right here. I will start at 20 foot-pound and work my way up to 30. If you are installing this for a John Deere 400, you may have to add this plate. This is a engine mount plate, so this will go over to your engine mounts, which are located on your main frame. I'll give you guys a close-up view on this installation and how to torque down the bolts, so stick around. just mounted the cover plate, I mounted the engine mount bracket, and 4 bolts are torqued to spec. Now the next thing I have to do, and not to forget, is install the snap ring which holds the radial bearing in place. I will install this first, and then I can push in my crankshaft seal, which will hold the oil within the engine from this side. I laid the engine block down, and off to the left of the screen I have a brand new piston rings, and wrist pin. The connecting rod I will be reusing because there's no damage on it whatsoever. I will share with you guys how to install your piston rings onto your piston, and then I will install the piston into this bore so we can connect the connecting rod to the crankshaft. On the white table I have the piston, the connecting rod, an oil ring set up, and 2 compression rings, as well as a brand new wrist pin. I have my feeler gauge right here because I will need this for the piston rings. And iSafe Tractors also gives you the sheet, or the spec sheet, for the piston rings and which order they have to be installed in. So they have 3 different styles, and the style I believe which we have right here is style number 1 for this piston. This is an oversized piston by 10 thou. I measured this piston beforehand, and this measurement is exactly 1/1000th of an inch actually oversized of what it actually should be. So I wouldn't say this is the best quality, but it is really good to measure your piston before you would rebuild your engine, because you want to make sure that your piston has the correct tolerance and clearance to your bore. This piston has been made by 1 thou bigger to the specification of this oversized piston right here. And now what I'm going to do is I'm going to go through the piston rings. The piston ring style 1 will have a top compression ring that has a shape which looks just like this. It is basically a rectangle looking at it, and on the bottom left hand corner it has a little chamfer. The chamfer will be facing up on the piston, and we'll get into that later. The second compression ring has a little step. They call this a scraper ring. This ring has a step on it, as you guys can see, and the step will be facing downward. As for the oil ring, this is a 3-piece oil ring. We have the middle section, which is wavy, and this will interlock just like that. And that will be the first thing we will have to install. After that, we will have to install the 2 smaller rings. These will be placed on the top and bottom of this ring right here. Now I covered the design aspect of the piston rings. Now I'm going to explain the piston ring gap and what we have to look for within our engine block. So this right here is the bore that I will be focusing on right now. I will grab the top compression ring, which has the bevel on it, and I will place it within the bore. So just like that, I want to make sure that this piston ring is horizontal within this bore. And for that, many people do use the piston to push it in and make sure that it is horizontal all the way around the bore. But that isn't a good measure, because the front of the piston is usually smaller and the back of the piston has these cutouts right here. So you technically can't put this piston ring all the way around the perimeter to the perfect depth. For that, I use a depth gauge. I'll adjust it right here, and I'll go all the way around the perimeter and push this in. And I want to make sure that I have an even gap I want to make sure that the piston ring is all the way around the perimeter at the right height.
just like that. Now I'll take my feeler gauge, and the gap has to be between 10 and 20 thousandths of an inch. Those are the specs for a brand new bore. So I'm going to start with 10 thou because I do see a little gap on the top by the piston ring. So I'm going to take the 10 thousandths of an inch and I'm going to try and fit it within the gap. And as you guys can see, it goes right in. So we already have a gap of 10 thousandths of an inch, and now I can go up to 11 and work my way up and see what gap we actually have. So that is 11, and I'll see where it grabs the most. "13 just goes in, so maybe 14 won't go in. As you guys can see, 14 thousandths of an inch does not want to go in. I think that is a proper gap right there, 13 thousandths of an inch. So it's not too big, but it's not too small either. So I will leave the top compression ring as is. I'll take the second compression ring and we'll make sure that the step is facing downward. And the same thing here, I'm going to place this within the bore. Make sure it's all the way in around the whole perimeter. Just like so. Now I'm going to grab my depth gauge and go all the way around the perimeter to adjust it to the right height. Just like that. Now I'm going to start at 10 thousandths of an inch once again and work my way up. 10 thousandths of an inch goes easily in. I'm going to step it up to 13 right away. 13 goes in very smooth. I'll try 14. 14 goes in as well, so we're going higher already. 16 does not go in, so I will try 15. See how that does. And 15 just barely goes in. So this right here happens to be 14 thousandths of an inch. So once again, I have a compression ring which is still at 14 thousandths of an inch. That is between 10 and 20 thousandths. So I do not have to adjust anything right here.
I just measured the piston ring gap, and the right side and the left side are perfectly within spec. So what that means is I don't have to open up any gap whatsoever. Everything is between 10 to 20 thousandths of an inch. That is the brand new bore spec of any Kohler K532. So in my case, I do not have to open up any gap. But if you guys have to open up your piston ring, I will leave a card up above, and I will link you to another video so you guys can watch me open up the piston ring gap in that video. Unfortunately, I wasn't able to do it with these piston rings as everything was just perfect, so I didn't have to do anything. So in my case, I can take the piston rings and mount them onto each piston. I will start with the oil ring first. That is the very bottom groove of the piston. I will start with that first. So I will give you guys a close-up view on this, and then we'll lube up these pistons and put them into this block. Both sets of pistons and the connecting rods are ready to get mounted within the main block. Now I have a piston ring compressor right here. This will help installing the pistons into the block itself. And before I install this, I want to make sure I use lubricant to lube up the cylinder wall and crankshaft bearings. Something really important to note is that you want your piston rings and the piston ring gaps always offset. So when we look at the piston from the top, you want each opening or each gap on 120 degrees. So the second ring will be right here and the first ring will be up above. So that's 120 degrees offset, as well as the oil ring. I want that offset as well. So I'm going to turn this over so that the gaps do not line up under each other. I want to make sure that they are offset when I look at it from the top. Once I like the way they're positioned, then I can take my piston ring compressor, put it over top of this, and start cranking it down. You guys just saw me install the pistons with the connecting rods. Everything is mounted onto the crankshaft, and now I can go ahead and torque the bolts down. I torque down the connecting rod bolts to spec and the engine turns over by hand freely. That's what you want to do after you're done torquing those bolts. You want to turn it over and make sure everything moves just the way it should. I did mention I was going to move on to the valves, but I think I'll move on to the oil pan first. That way I can add the oil pump and the gear for the crankshaft. Everything will be assembled on the top face by the crankshaft and on the bottom face of the engine. So then we can lay it on the oil pan, and then we don't need any blocks on this table anymore. Everything is laid out right here on the table. I have the oil pan. This is one cast part which holds the starter and the dipstick tube, as well as the drain tube. This will bolt on with these 4 bolts right here. They all have lock washers on them. They will get inserted below the oil pan, just like so. They will come up into the block from the bottom, and they will get held on this thread. This pan also has 2 dowel pins, so they locate the oil pan to the engine block. The first thing I will mount is the timing gear. Since this has a slot for a key, I will put this on right away. I will hold this in place with the snap ring afterwards. Once this is installed, I will go ahead and mount the oil pump. The oil pump is held in with 2 bolts. And once the oil pump is in place, we will mount the pickup screen. This screen will merge onto the pickup tube, just like so. And I will share with you guys how all of this gets installed, and I will share with you guys this sequence. So I mounted the timing gear on the crankshaft and everything went on super smooth. I heated it up a little bit so it'll slide on better. After that, I had to tap it down just a little bit so I can put on the snap ring. Once that was installed, I moved on to the oil pump. The oil pump is in place and I made sure that the gear has a little bit play from left to right between the teeth. So now I'm going to move on and add the pickup filter. Once that's installed, I can then mount the oil pan. This is the pickup filter. I cleaned this out with compressed air. Everything on the inside and on the bottom is very clean. We have to put the pickup tube within this bore, and there's a little slot which will hold our securing pin, which is this right here. Close to the oil pump, we have a smaller end facing out and the bigger portion facing in. There's more area or more space on this side, and there's less space on this right side of the screen. So that's how we're going to mount it, just like that. I'm going to make sure this is hooked up. That will hook up right in there, something like that. And now this oil filter, or this oil pickup filter, is going to sit just like that. Now I have to keep it in that position. It's going to look something just like that. And now I'm going to have to make sure the surface is clean around the perimeter, as well as on the oil pan. Then I'm going to add silicone around the perimeter, add my gasket and a little bit of silicone again, and merge these two parts right here. So you guys just saw me install the oil pan onto the engine block. This is an aluminum oil pan, so I torqued the bolts down to 30 foot-pounds of torque. That's at least what it says in the manual. If you do have a cast oil pan, you'd have to torque the bolts down to 35 foot-pounds of torque. Now I can move on and install the exhaust and intake valves on each cylinder. Once the valves are in and the springs are in place, I can adjust the valve lash. That is the gap between the lifter and the valve itself. I'll share with you guys how to do that. Once that's done, I can install the head gaskets and heads and torque all the bolts to spec. So let's dig right into it. On the table, I have the left and the right set of valves, which will go into my engine block. Right here, it happens to be an intake valve. I cleaned everything up and the shaft seems to be still in great condition. There is no groove and there is no wear in it. On the 45-degree surface, I cleaned everything up, and I also lapped these into the valve seat, which is in the engine block. You guys will see a rough looking ring around the whole perimeter of the valve, but that is lapped into perfection. I'll give you guys a close-up view so you guys can see the lapping compound did a great job, and in the valve seat in the engine block as well. For each valve, we have a spring, and we also have keepers, which will hold the spring in place as well as hold the valve. On the exhaust, we have the exact same setup. It says exhaust valve on it. We have 45-degree once again, and we have the lapped surface as well. So I'm going to install the valves on the engine block, and I'll give you guys a time lapse on how I do this. So I just installed the valves, valve springs, and the valve keepers. The valve keepers hold everything in place and everything seems to be just fine. I have this self-made tool right here. All it is a clamp. It is a mechanical clamp, and then it opens and it is spring loaded. So this clamp on the very tip, I just made a U cutout. So what I can then do is go around the valve stem and I can compress the spring, and after it's compressed, I can add the valve keepers. This portion of the clamp is very thick. On a proper tool, this is very thin, so you have room to actually put in the keepers, but I did manage to put in the keepers using this tool I customized right here. This worked pretty good for me. If you guys don't want to customize your own tool or even damage a good old clamp, you guys can go out there and purchase the proper tool. Now I'll move on and share with you how to adjust your valve gap. That is the gap between your valve stem and your tappet. This gap is really important because once the valve opens with the tappet and closes, the retraction is so fast that you do not want the valve stem to always bounce on the tappet itself. So the tappet will ride on the camshaft and the valve will retract by the spring, but hopefully not touching that tappet. So we want to make sure that clearance is to spec, and the cold specs are on the top right over here. So we'll go based off of the cold specs. We'll adjust the intake and exhaust. They have different values, and I'll start with the exhaust first, which is a bigger value, and then I'll move on to the intake. So to start off the procedure, the camshaft is sticking out right here, and I'm gonna add the nut which will hold the camshaft gear. I'm gonna add that to the camshaft right now, even though the gear is not on there. This will allow me to turn over the camshaft without any problems. Now I'm gonna grab a 1 1/8 socket so I can turn this camshaft over, and that'll look something like this. You will see that all the valves open and close just the way they should, and this will allow me to find top dead center on each tappet, which is powered by the camshaft. Another thing that I will need is a 1/2 inch wrench and a 7/16 wrench to adjust the tappet length. These tappets have an adjustable tip, and that's how we will adjust our clearance between the valve and the tappet itself. I will start on the exhaust side, that is this port right here, or this valve, and on this side it is the one that is further away. The exhaust in a cold state should be between 17 and 20 thou. I want to go as small as possible because it can always get bigger, and I will go for 18 thou. That's going to be my measure for the exhaust today, and later on for the intake it's between 8 and 10 thou, so I will also go right in between, and that will be 9 thousandths of an inch. So right now I'll try and get the 18 thou fitment right in between the exhaust. The first step is I'm focusing on this valve right here and tap it, and I'm going to turn it over to find top dead center. That's the very top, and I'm going to release it, and it should come back by itself just like that. Okay, now we have play in between. As you guys can see, that's moving back and forth right there, and I'm going to push the tappet in to the camshaft and see how much play there really is. Right now 18 fits in there, so I'm going to see how much more really does fit in there. I'm going to go with 22. 22 does not fit, so I'm going to go lower. I'm going to go with 21. 21 does not fit, so maybe we're actually already within spec, but maybe we have to adjust it just a little to get to 18. 20 just doesn't fit. Let's try 19. Seems like 19 is just grabbing. Let's try 18. 18 just fits, but I want to make it a little bit more snug, so I'm going to grab my 1/2 inch, put it around the tappet, and 7/16, which is up front, and I'm going to make it a little bit smaller by turning it clockwise. Just like that.
Doesn't need much. I'm gonna go with my 18th thou once again. Still fits in there. I'm gonna make it a little bit smaller. And just like that, it's grabbing. And as you guys can see, it's just letting go of the feeler gauge. So it can just slide in with very little restriction. I finished up the valve gap. Everything seems to be just fine. Everything measured good. And now I can go ahead and close off the cylinders with the cylinder heads. For that, I have brand new head gaskets. These are very good quality. And after I put that on, I'm gonna have to torque down the bolts from the middle outward so there's no stress within the cylinder head. So I can do that, torque those down, and then I can also close off the valve covers. So let me give you guys a close-up. cylinder heads, the valve covers, and the oil filter adapter. Now I have a whole bunch of parts laid out on the table, as well as a couple gaskets that I will have to install on the front face of this engine. This part of the engine will be the timing cover gear as well as a timing cover adapter. So there are two plates that I'm gonna have to install, as well as the cam gear that goes in between. We're gonna have to get our timing set up. Once that's all done, I can close it off with the cover itself, and then I can tighten up all the bolts. Off to the left are some of the tools I will be using. I have blue gasket maker. These are all the bolts for the timing cover. This is the adapter plate. So this will bolt directly onto the engine housing. I already had this on before just to keep the camshaft in place. But now I have to add that gasket right there behind it. So that will be on this face. We will bolt it up with these three bolts like I did before, but then we will torque these to spec. Once that's in place, I have to come over here, grab the cam gear, put it on, tighten up this nut to 40 foot-pounds of torque. So that is this thread and this nut right here. And before I tighten it, I also have to make sure the timing is set up between the crankshaft and the camshaft. Once that's done, I want to get this other gasket, put it in place on top of this adapter plate, and make sure that the cover goes on smooth with the seal already within the timing cover. So I have the camshaft gear right here. I have gloves on because I heated this shaft up, so it's easier to put on the camshaft itself. On the camshaft gear, we have 2 dots. I made them yellow so it's more visible. And on the crankshaft gear, we only have 1 dot, which is this yellow dot right here. These gears are on an angle, so you want to make sure that the back end of these gears mesh first so that the front lines up. And I'll show you how that looks like. To put it on the shaft properly, you might want to wiggle it a little bit back and forth, just like that. Now I'm going to go ahead and take the nut and start tightening it. Just like that. And now we're going to have to torque that nut down to 40 foot-pounds of torque. I have my torque wrench set to 30 foot-pounds for right now, and I also have a piece of plastic which I will wedge right in between the 2 gears. So as I tighten this up, I have something to keep the gears held in place. I wouldn't know how else I would hold it. Maybe even a piece of wood would work, but with the piece of plastic, it's a little bit more safe. So that right there is 30. And now I'll go up to 40 foot-pounds. Like that. Just like that. That's now torqued to spec. I'm gonna focus on the gear cover right now. The lip seal is already in place. I pushed that all the way down. There is a stop, so it won't go all the way through. You guys can just push that all the way in. And now before we install this cover, we have to get our gasket. I'm gonna put on both sides of this gasket a little bit of silicone. And before I push this cover on, I wanna lubricate this seal so it's already lubricated. And then we will push this on and torque them down with these extra long bolts here.
engine is already taking shape and there's not much left for the Kohler K532. I have the intake manifold, the governor, the carburetor, stator, and the flywheel. So not many parts are left. I have just 5 more gaskets. I'll mount everything back onto the engine, and then I'll give you guys a final review of this engine assembly. The last thing I had to mount onto the Kohler K532 was the carburetor, and I mounted that to the intake manifold. This is still a raw engine. There are no panels and there are no throttle cables and whatsoever. This is purely an engine rebuild, and that's how I kept this video. I gave you guys a detailed view on how to rebuild this engine from ground up. I personally will go ahead and mount more onto this engine as it's for my John Deere 400 garden tractor. And before I even start this engine up, I want to do a test run. So I'm going to get all the shrouds on this engine. I'm going to get the throttle and the choke linkage set up, the air filter, and all that good stuff to start this engine for the first time. So I will give you guys another video on this. I will put it on a stand and I'll start it up for the first time. If you guys enjoyed this video in any way, if you guys just needed to take a little detail out of this rebuild process, I'd really appreciate it if you guys give this video a thumbs up down below. I'd also appreciate if you guys leave a comment down below. It gives me some feedback when I'm doing good and what I could improve in. I really do take your guys' comments seriously, and I try to respond as soon as possible. Consider subscribing if you haven't already, as I'll always have some new videos on machines or engines in general, and I'll see you guys next time in an upcoming video.